Hello and welcome all. Today we'll be taking a new topic, and that's about a very sought after and very interesting and informative topic about mastering state management in Blazor, and which is a comprehensive guide. Now, this entire tutorial is based upon my blog, which will be in the description, and it will discuss the various management approaches for the state management, namely component state, service state, application state, and the persistent state. So with complete coding example with a Blazor assembly, so you are in for a very interesting time. So please remain seated with your headset glued, and let's now flip over to Visual Studio. But before that, let me introduce what is state management. So it is a method by which a web application maintains, manipulates, and tracks changes to the application state during its life cycle. And in Blazor app, state management becomes critical as Blazor apps can run client side where maintaining state across the sessions can be tricky. And also, application state can be anything. What is a state management after all? So this application state or the state that we are going to manage can be anything that the application needs to remember between requests like user input, server responses, and cached data and more. So there are multiple methods for managing state in Blazor application, which I have started at the beginning. I have told about component state and service state and application state and persistent state. So if you persist with me for the entire duration, I'll be discussing everything in detail with code examples live. So let's flip over to now Visual Studio. So now I have flipped over to Visual Studio 2022 and I will create a new project, and this is one of the recent project template Blazor Web app empty. So I'm going for an empty and I'm going to write every code myself. All right. So for the benefit of this tutorial and for the sake of brevity, I'll be copying and pasting most of the codes, but I'll be explaining everything in detail from scratch. So state management, let the project be named as demo. Okay. And click on next. ASP.NET 7 standard term support, and I don't need it to be ASP.NET Core hosted, and neither it is a progressive web application, so you can even get rid of configure for HTTPS, which is not necessary to explain this tutorial. So click on create. All right, so the project is created for me. So you can see for an empty template Blazor web application app, all you have got is a www routes folder, and there is a pages folder with imports.razor and app.razor and main layout.razor and a basic skeleton program file, which is an application startup file. Okay. Now all you see in the pages folder, which is where all the razor components that I'm going to build in this Blazor's WebAssembly application is in this pages folder, and index.razor has got just a hello world. So at the moment, if you run this application, it will come up with a hello world, which is as expected. So I will not run this application. We'll save some time and we'll go to the next thing. So the next thing is I will create a razor component. So add a razor component and name this as component state. Okay. So component.razor. So I'll just add the word component state, makes typing a bit easy. Now to keep the tutorial short and not to bore you with the code, coding line by line and letter by letter, which will take a huge amount of time. So I will just paste the code that I am on my clipboard and I will start explaining everything. So I've created a header, a component state, which will be writing clearly that it is component state. And by the way, let us put a page directive, at page for navigation purpose at page within double quotes. Let me write it component state or okay. Let's write the whole thing component state. So this is for navigation purpose. So when you navigate to this page, it will be through localhost colon the port number slash component state. Okay. So and you can only have one page directive at the top of the page in a Blazor application. So here you can see the current count is at the rate current count. So at the rate current count, what is this? This is the, it takes the value of the current count and there is a button markup which has got this class, and on click event of the button, it calls the increment count method, which is nothing but incrementing the current count by 1 every time you click it. So let's run this application, and this is simple straightforward application which you could also create by a Blazor WebAssembly template. So let's see, and hello world. So let's browse to component state. So it's loading. So current count 0, if you click on, it will continue incrementing the counter as expected. So, so here the current count is the state in this component. So we initialize it with 0 and increment it by 1 every time the click me button is clicked, which I have shown you. The on click directive is a built-in Blazor event callback that wires up the button's click event to the increment count. Okay. Every time the state changes, the increment count method is called and Blazor automatically re-renders the component updating the displayed count, and I have already shown the running version of it. Now let's discuss service state. So in Blazor, services are often used to share state across components. We use ASP.NET Core's built-in dependency injection framework to register and retrieve services. Let's modify our counter to use a service. So let me first create a class named counterState in the project root. Okay. So public class counterState. Now since this is a small code base for this counterState class, let me write it. So instead of my property, we'll name it current count. To store the current count, and this is get, and instead of just set, you can make it private set. You could keep it as set, but you could set it so that it cannot be changed outside this class. Okay, and then a public void method known as increment count. Where you are just increasing the current count property, incrementing it by 1 every time the increment count method is called. That's it. This is the counter state. Now let's visit our program class, our startup class, and we have to register this service. Okay. So what I will do is here below this builder dot services, and I will add a singleton and register this counter state. Counter state class. Okay. So it's all done. Counter state is registered. Now we are in a position to inject this counter state component or counter state class, counter state type into any component. Okay, so let's create a service state component within the pages folder. Service state component. So let me give a page directive for navigating purpose at the top. Since we are testing service state, so front slash service state, that will be the URL following HTTP colon the port number. All right, so header is there already, and here I need to inject the counter state that we have just built. At inject is the statement. So it's basically, it is injecting type means I am injecting counter state. I'm creating an object, you can say, so that this counter state can be used in this uh, markup. Now I'll create a button, and on click event, I will tie up the increment count method which I am going to write. So increment count, it's still not there, so it will say it doesn't exist in the current context. So don't worry about that. So we'll fill it up all, and we'll call this button click me or click or whatever. And then on a paragraph, I will make the computation of the current count. So current count, I will use that current counter state which I've injected. Counter state dot current count. Okay. So now all I have to do is to fill up this method, create this method. So that's the same method. Now here the only difference is, just follow me, I will explain everything. You could argue that I should have built this method first. It doesn't matter. If you are a experienced programmer, you will encounter many such occasions where you have to fill up the gaps, fill up the methods later after creating the code that uses those methods. So I am using this counter state dot increment count. So what was counter state? Again, you have got this counter state class. It has got increment count, which increments the current count by 1. Okay, so come back. So here I am going to use the counter state current count. Counter state's increment count. Okay, increment count. I am calling this method for the counter state which has been injected on the top. So here this increment count will do this way, okay, by the counter state service which was injected. Now let us run this application and browse to front slash service state. So localhost colon port numbers slash service state. It's loading, a bit of time is gap is there. So click me and the count increases. All right. So that's also taken care of. Now let's do some explanation about this. So like I said before, the services in Blazor are often used to share state across components. And here we use the ASP.NET Core's built-in dependency injection framework to register and retrieve services. Okay, so this was actually quite simple to understand, that we created a counter state and then we injected it in a service state component where actually the current count is uh, given when the button click event, which is tied up to the increment count method, and that actually gets the increment count. It calls the increment count from the counter state method and counter and writes the present count as counter state dot current count. When the button is actually on click event is hooked onto the increment count method, and paragraph the counter state, the injected value is bound to the current count. So increment count and current count both are used. So you can see counter state increment count is also called, and current count is also used here to give you the current count. Welcome again. Now is the time to discuss application state, the third procedure after we have followed the component state and the service state for Blazor state management. So when sharing state across the whole application, we often use a store pattern. Application state represents data that your application needs to maintain over time and across user interactions. This data is stored in a central location, often a store that can be accessed from any component in your application, and the stores typically exposes methods for changing the state and an event that is raised whenever the state changes. The components can subscribe to this event to be notified of the state changes, which allows them to re-render and reflect the updated state in the UI. This concept is similar to libraries like Redux in the JavaScript world. This is a bit more advanced, but it's a robust way of managing complex state. So let's create a basic store for our counter by creating a counter store class at the root of the application. So add class. Previously we have created counter state. Now we are going to create counter store class. All right, this is our counter store class. So on this counter store class, what we need to do, our code will be, first we'll generate a public property. We'll create a public property of type int, that is count. So again, prop tab. So public int count get, you can again keep it like private set, like we did for, if you remember, we did it for the other counter. For counter state also we provided a private public property current count. So here also just count. You can make it current count or count. Yes, choice is yours. Okay. Then we are going to create an event. That's also a public event. Of type action. Okay. On change event. So this is the syntax of writing an event. So it's a action type is encapsulates a method that has no parameters and doesn't return a value. Okay. It's just like a method, void method that doesn't take any argument. Okay. But additionally, it has to be qualified with an action. Okay. And that action is, it encapsulates a method. Okay. Again, our familiar increment count method. Where you could guess correctly if you have guessed, I'm incrementing the count. But additionally, I am calling a method notify state change, which I am yet to write. And I will explain everything Just give me some time. Notify state changed. And what this notify state change method is, it doesn't exist in the current context because I have not written it. So what this method is, it is a doesn't return anything, private void. Notify state change, and what it does is it is calling the on change event. On change, there is a the syntax is question mark. Where is the question mark? Dot invoke. So when the this event, whosoever subscribes this is event and subscription type of model. So whichever component subscribes to this event on change, then this notify state change is invoked. So on change dot invoke, what it says, uh, this one is actually doesn't say anything on the mouse over, but it invokes. Okay, it is invoked. Like before, we also registered this counter store in our program class. So I'll just copy this line. So counter store. Okay, it is properly registered, and counter store is here. And now we'll create another component, which is we already have service state and component state. This is application state. So add user component, call this application state, because that is what I am going to discuss. Application state.razor. It will take the razor extension automatically because this is a razor component. So application state. So as usual, can you see what I am going to write on top? Yes, it is page directive at page within quotes front slash say application state. I think there should be a gap, and yeah, application state, service state, application state. Okay. Now, as before, like we did with the service state, where we injected the counter state, now we are going to inject the counter store in the for discussing the application state, for writing the code for the application state.razor component. So at inject counter store, you could write a smaller name like store. Okay, so that's it. And then there is a application state header which will prominently show that it is coming from the application state component, and then the button on click event. On click, I think it has to be added. On click, increment count, it's not there, so it will protest, it's not there. Now for this is a bit of a longish code, so I will use my clipboard where it is all copied, and I will just paste it over there. So within the code block, at code block, I'm going to write this increment count. Now this is squiggly line is gone. So it has got on initialized method and increment count method. This is a lifecycle event, Blazor lifecycle event. Okay. And this is update count method and dispose method, which disposes, which unsubscribes after the when you are closing the application. So it is releasing the resources. So let's first run the application and then we'll start discussing. So again, this is being routed to application state for doing the correct um, application application state. We cannot afford any typing mistake or typo. So application state, click me. Uh, Nothing is happening at the moment. So troubleshoot. The simple reason, can you point it out? Uh, After the button on click event is tied to the increment count. But when you click it, it should give the output somewhere, right? So, and that output will come from this count by, so I forgot that. So this piece, let's write. Sometimes we learn by doing omissions and commissions. So current count equals simply at count. And how this at count works? So count is counter store dot count. Okay, so counter store, what was counter store? Counter store is this component that we have the injected and count property over here. Okay, and on change event it is subscribed to. So on change, what happens whenever the count is changed? Update count is called, and update count is actually um, getting it from the updated value from the counter stores count property, and it is raising state has changed, which is re-rendering the component. Okay, it notifies the component that its state has changed. When applicable, this will cause the component to be re-rendered. Now let's do it again. Run the application again. Okay, that's all right. Okay. Now let's do a bit of a theoretical discussion. So we have seen that the application state, we have used an event-driven approach because we have written an event over here. Okay, we have created an event, on change event. So when dealing with the application state, the event-driven approach means that when a state has changed, and when the change happens, when the state change happens, an event, which is an event, any interested party is subscriber, which is an interested party, gets notified. Okay, so let's see the counter store example. Now, on change here, what it does, this event is gets raised whenever the state, that is in this case the count changes. So notify state changed is a helper method that raises the on change event. Okay, on change dot invoke means it is raising the on change event. It checks if the event has any subscribers on change. Okay, so this subscribers it will found from here. Here it is on initialized method in the actual result component on the lifecycle on initialized method. So it then calls the update count. And because it has found there is a subscriber, so it invokes them, and any component that wants to react to the state change can subscribe to the on change event. And as I just said, that update count is a method that gets called whenever the on change event is raised. We subscribe to the event in the on initialized lifecycle method. Now lifecycle methods in Blazor give you the opportunity to execute code at specific times in a component's lifecycle such as when it's created, when parameters are updated, or when it's about to be rendered. In our example, we use the onInitialized method to subscribe to the onChange event as we have seen. So this method is called once after the component is first initialized but before it is rendered. And when the component is disposed of, it's important to unsubscribe from the onChange event. This is unsubscribing from the onChange event to prevent memory leaks. And in this update count method, this state has changed method is called to tell Blazor that it needs to re-render the component. Okay, because in this method we are updating the count variable to reflect the new state. So the state has changed. Method is called to tell the Blazor framework that it needs to re-render the component. Now this whole process of maintaining a central application state, notifying subscriber of state changes and reacting to these changes is a fundamental pattern in modern UI development, not just in Blazor, but sometimes it is used in rather liberally in frameworks like React and Vue.js. It allows you to build complex interactive applications where different components can stay in sync and react to the shared state changes. Okay. Now, lastly, let's take the persisted state that involves storing the state in a location that survives page refreshes and even browser restarts, such as local storage or session storage. It can also be stored on a remote server or a database. This process involves serializing the state, sending it to the storage location, and then deserializing it when it needs to be accessed again. Now we'll have to use blazor.localstorage NuGet package to persist our counter's state in local storage. Okay. So accordingly, I searched for blazor.localstorage by Chris Senti. It's 4.5 million downloads. Okay. And then the latest stable version, we install it. Okay. Click on OK. So this is all installed. So you can find this is in the installed components. Okay. Uh, right. And then let's close this window and we'll have to register the service in the program file. So accordingly, I have registered it in the our program class builder.services.as add blazor local storage. Okay. Now, in line with our approach in this video, you can see a tutorial of keeping separate components, Razor components to discuss the distinct state management approaches. Let us add a component, Razor component, which is known as persisted state or persisted state. Okay, yeah. So persisted state is there, and let me put a at page directive to for ease of browsing. At page persisted state. Okay. Now here I need to inject both the counter store as well as the local storage, blazor.local storage. So accordingly, I inject them one by one. Blazor.localstorage.iLocal storage service, local storage. Okay, and then persisted state will come nicely in the H3 header. Okay, now let's paste the very usual code over here. This is the wrong one. So I wanted to paste this part. Okay, increment count and at count are not there. So I'll create them. So this part I will actually choose to just copy it from my clipboard. So excuse me for that because this is getting too long otherwise this video. Now this will take care of all the squiggly lines, increment count and at count. It is gone. And in local storage is a web storage object that stores data with no expiration date. This data remains intact even if the user closes the browser window or turns off their system. It's ideal for persisting data between sessions or to enable an application to be available offline. So local storage is a key value store. Okay, meaning, so this is the key and this is the value we have seen, meaning that you store data as a pair of keys and the values, both keys and values are always strings. And the Blazor.local storage NuGet package provides a convenient way to use local storage in Blazor applications. In our application, we use the local storage service to persist on the counter state. The on-initialized async lifecycle method, we retrieve the count from the local storage. From the local storage, we are retrieving the count again. I'm just revising the things once more. Using the get item async method, if there is no value associated with the count key, this method returns a default value for the type, a 0 in the case of integer. Okay. Every time the count is changed, the update count method is called. We update the value in the local storage using the set item async method. Now, it's important to note that while local storage is convenient and can be very useful, it has several limitations like limited storage. Browsers typically allow up to 5 MB of data per origin, and performance wise, reading and writing to the local storage is a bit slower than memory. So it should be used judiciously. And finally, there is a slight security issues. Local storage is accessible through JavaScript, which makes it susceptible to cross-site scripting attack, XSS attack. Therefore, you should never store sensitive information in local storage. Despite these limitations, local storage is a powerful tool for persisting non-sensitive data across sessions in a Blazor application. So, in summary, we have seen that the Blazor offers several strategies for state management, each suited to different scenarios. Component and service state is ideal for managing local and shared state, while application state via a store is used for more complex scenarios. Persistent state allows you to maintain state across sessions. Thank you for watching.